Hello. Today we will talk about macroses and in such a special case of usage and of thinking of them. So, slightly provocative name of this snail is can macro be first class? It means first class citizen, which can live at runtime, which can be passed as arguments to the functions, returned as a value, and so on and so forth. And I'll try to describe my own thoughts and my own point of view about it. First of all, I'd like to say that a lot of people said that it sounds like oxymoron, because macroses cannot be a first class and cannot live in runtime. Otherwise, they are not macroses at all. You can name it f expressions, you can give them other names, but please don't mix up runtime and macroses. But let me introduce my point of view and my opinion of it. First of all, what is macroses? Usually all of users of languages with macroses, thoughts of them like about some syntax sugar for creating syntax abstraction, for a usable way to expand syntax of the language, and for creation such complex structures with short and usable manner. But as we saw previously in previous snails, for example, let macro can create even a semantic abstraction. It can create a local variables if they are not integrated in the language itself, like in language scheme. They are not so-called local variables in scheme. Only formal parameters of lambdas exist on the low level. But let macro allows us to emulate so-called local variables and we can deal with them as with usual local variables. They can be mutable in schemes even more than in Clojure. But in this case, I'd say that macro allows us to create even semantic abstractions, not only a syntax one. But let's cover a little bit regular macroses. A lot of languages with macroses have so-called macro expansion stage. Then it can be interpreted core code, or it's a core code for transpilation in other language, or preparing for compilation in the binary file. It depends on the implementation of language. So again, I'd like to say that there are no such things like interpreted or compiled language. It's an oxymoron from one point of view. Language itself is a combination of syntax and semantics, and that's it. It's no talking about would it be compiled or interpreted or so on and so forth. Because for any language there can be either interpreted version or compiled version, or different interpreted versions or compiled versions which will support the same semantic and the same syntax. But let's return back to the macroses. If language processing has a special separate step of macro expansion, it allows us to do some interesting tricks. For example, we can add optional typing to the language, like it can be implemented in Clojure, or do some other things. Relying on that on macro expansion stage, we can also have a so-called error of macro expansion. They are very similar to the error of compilation, error of type checking, and so on and so forth. So we have now to wait until runtime where when error will occur, so we can catch them on macro expansion stage. So if we evaluate this expression, it shows, wow, syntax error, max expanding Clojure core cont requires an uneven number, and so on and so forth. So that's the error of a macro expansion stage, and this trick allows us to have special possibilities for using it for our purposes. But in Clojure, macroses are actually not a first-class citizen. Due to the same way of macro expansion time. After macro expansion, we will get the so-called Clojure core code, which uses only special forms, only symbols which represent lambdas and some first-class citizens and some literals as strings and numeric and some other things, but not macro itself. So we can do such thing. We can evaluate this form, define a variable e value of let macro with a mistake can take value of macro. So in runtime we cannot take value of macro. We cannot ask the type of let, because also we cannot its value at runtime. That's cause of totally separation of macro expansion stage and runtime stage. But on the other hand, macros is created for evaluation before what actually? Before the code, before the executable part of the model or so. Actually, it have to be evaluated before evaluation of the form. But evaluation of the form itself can be also prepared in runtime. And we can create such type of macroses, so-called macroses, I'd like to call them macroses, which will, as lambdas, the same way the first-class citizen, which will holds as a special type of runtime of language, and have their own evaluation strategies. In terms of lambda expressions and in terms of lambda calculus, there are two radically different evaluation strategies as reductional strategies of lambda terms. Normal strategy and applicative strategy. And applicative strategy means that we first evaluate all the arguments and then evaluate terms depends on these arguments. It's a regular way for evaluation functions in every languages. But normal strategy is about that we're trying to evaluate the term itself first before evaluating its arguments. It's actually like macroses works, and it doesn't. It's not so big difference when we will evaluate this macros by normal strategy on separate macro expansion stage or in the runtime itself. For example, I can show you my little language. I called it Liscript. I made a lot of implementations of them, and here I implemented macros as a first-class citizen, and they are present in runtime. For example, there is OR macro. Why we can not have OR as function? Because if first argument of OR is true, then we have not to evaluate all the other arguments. And we can do such tricks. Def, for example, variable a is a list of OR and maybe 42. And yes, we ask a, it's a list of two arguments, and we can evaluate such type of things. First element of list a, and then two logical expressions. And maybe some other expression. And that's false, because not 10 is less than 3 and not 5 is less than 2. And it works because we get the first value of list A and actually is a macro, and it's evaluated as a macro. So that's an example how macroses can be a first-class citizen in this language, and of course it has no special separate stage of so-called macro expansion stage. And we have a pros and a cons of such type of things. For example, at runtime, every time we have to evaluate the macroses, we have to do macro expansion step in runtime. Every time, not once at the so-called macro expansion time. But let's return back to the Clojure. And finally, I'd like to say that it's not only one way how to implement this syntax and more wider semantics abstractions and semantic possibilities such gives us by macroses. We can do it many ways. We can have even we can have both ways, both worlds. Separate a special macro expansion stage, and at the same time we can have another type of macros, so-called. maybe we can call them f expressions and so on, and having them at runtime as first-class citizen. That's maybe enough for this exact nail. In the next nail, we will try to emulate the macros' behavior without macros itself. Thanks.